This invention will truly revolutionize bicycles of the future, especially all-terrain and mountain bikes. As we know, analysis of all-terrain and mountain bicycle suspension systems have shown three distinct behaviors while in motion. Air or coil springs absorb the impact energy that comes from the wheels. Therefore, they are set right above or around the wheel hubs, which are often referred to as front and rear degrees of freedom. Hydraulic rebound damping controls the wheel's return after the impact. Therefore, they are also set right above or around the wheel hubs at the front and rear degrees of freedom. Finally, as opposed to the first two, spring and rebound, compression damping minimizes the heaving movement of the chassis when pedaling and/or pitch movement of the chassis when braking. Therefore, it is most effective to set compression damping around the chassis or around what is referred to as heaving and pitch degrees of freedom. In our current traditional all-terrain bicycles, springs and rebound dampers are normally located in their proper locations, that is, at the wheel hubs. Therefore, only compression cartridges must be actualized for a fully integrated suspension system. The first performance test of FSS was carried out and is illustrated in this circuit. The circuit has an uphill section where pedaling behavior was analyzed. After the downhill section, a sudden slope change generates an impact. And finally, the bicycle was brought to a hard stop by applying the brakes. The same test was repeated for each of the four regulations, and this video compares the front suspension action for the different regulations simultaneously under the same exact conditions. You will notice how front suspension movement is low during pedaling when pitching is active, and the front suspension movement is high on the impact when pitching or heaving is active. Furthermore, you will notice that the movement is low upon braking when heaving is active. Next, the researchers looked at the behavior of the rear suspension in detail. The researchers analyzed the rear suspension behavior for the four different regulations accordingly. This video compares the rear suspension action for the different regulations simultaneously under the same exact conditions. You will notice how rear suspension movement is low during pedaling when pitching is active. Conversely, the rear suspension movement is high on the impact when pitching or heaving is active. And finally, the rear suspension movement is low upon braking when heaving is active. These were the final results that were observed in the field tests conducted by the Tekniker researchers. The movement is maximum when both degrees of freedom are open, and the movement is minimum when both are closed. Therefore, the behavior of the full suspension system is similar to traditional suspension when both degrees of freedom are fully open or closed. The closing of the heaving degree of freedom and keeping open the pitch degree of freedom results in greatly reducing the pedaling movement while impact absorption capacity is maintained. This results in a very good starting point for an optimal setup for the uphill sections. Meanwhile, when the heaving is open and the pitch closed, braking movement is greatly reduced while impact absorption capacity is again mostly maintained. This results in a good starting point for an optimal setup for the downhill sections. These results demonstrate that compression setup around heaving and pitch degrees of freedom can result in an easier setup of the suspension and a better balanced and smoother performance of the suspension system as a whole. In conclusion, this new discovery and novel invention by Tekniker will dramatically change all-terrain and mountain bicycling in the future, rendering rough riding a thing of the past. With the issuance of the patent on this IP, We are now seeking one or more bicycle manufacturers in the cutting edge of technology as our licensing and commercialization partners for the Tekniker self-balancing, fully integrated suspension system.